GATE 2016 Set 2 Electrical question number 16. Parallel plate capacitor filled with two dielectrics is shown in the figure below. If the electric field in the region A is 4 kV per centimeter, then the electric field in region B is being asked. So 4 options are given. So in order to solve this question, first you need to understand few basic things. So in a capacitor there are two metal plates, as you know. These are metal plates. In a parallel plate capacitor, these are metal plates. So this is region A and this is region B. Now you know that the potential of all points of a conductor should be same. So if the potential difference between these 2 points is V, then the potential difference of these 2 points will also be V, because these points are in the same potential and these points are in their own same potential. So the difference always is constant irrespective of what is inside the medium or what goes within this part. So now we are filling this region A with dielectric of epsilon r equal to 1, that is relative permittivity is 1, and here in region B relative permittivity epsilon r is 4. Let us shade this region. So this region is 4 and this region is 1. This is a parallel plate capacitor, distance is d, and potential difference between these two plates is given as V. Then the electric field between these two plates, electric field E vector from plus to minus, is given by P by D. The capacitance C is given by A epsilon by D, which is A epsilon naught epsilon R by D. Now there is one basic point I want to specify in this problem, that given that the potential difference between these 2 points V, then between these 2 points also the potential difference should be V, and between these 2 points also the potential difference should be V, because charges are conserved. Charges are conserved so you cannot change. If the charge is Q, it will remain to be Q. Partially introducing some dielectrics, since we knew Q equal to CV, so charge is conserved. Introducing some permittivity, so the C will change and the V will also change in order to maintain the charge conserved. In this question also the charge always remains constant, because there is no path for the charges to flow and combine, so the charges will always remain constant. But here in the question they have given what? The electric field at this partially introduced dielectric point they have given. So with respect to this electric field, we have to tell whether this region's electric field is constant, increase or decrease. But before this arrangement, before introducing this dielectric plate, the potential was different, because Q equal to CV. So effectively you are changing the capacitance by introducing a partial dielectric like that. So the voltage must change in order to keep that Q constant. But what they have done, after effectively introducing the dielectric plate and after the redistribution, once you have the combined C, for that you have a combined V to keep the charge constant, because these two capacitors are in parallel, so you get a effective capacitance. So with that effective capacitance to keep the Q constant, what is V? They have found out. So for that V, we are specifying that the voltage is constant with that V. But it was different once these two the dielectrics were not there, because then C was different. So for that different C, a different V comes into picture to keep that charge constant. So don't confuse this. So electric field is specified in this question is in this setup only, partially introduced dielectric of ER of 4 and ER of 1, that is relative permittivity of 1 and 4. In this situation only they have specified the electric field. So for this for this setup a particular V is existing, and that V will be constant all throughout the plates. That is what we are trying to tell. Now for example, for the same capacitor plate initially having charge plus Q, consider two situations. One is filled with air, and again we filled full plate with some ER, say material, or ER having relative permittivity ER. So in this case, in first case, what is happening, that charge is constant. Okay, so capacitance and voltages are C, that is as you see increases with ER. So here C will be more, here C will be less, and since Q is constant, here V will be more and V will be less. Similarly, here electric field, as V is more and D is constant, electric field will be more, and here electric field will be less by ER times. So E here is equal to E naught, which is here, and divided by epsilon R, that is E becomes E by epsilon R times, but charge is constant. But here the question is something different, because here is the same parallel plate given, of potential difference is then becoming fixed constant. So electric field also becomes constant since D is constant. So E is constant. So here you cannot change the potential by simply partially introducing some dielectric some value here and dielectric some value here, because that will not change the potential. Here in this case the potential difference is constant, and it is some C1 value is here and some C2 value is here, but V is constant, right? So solution, these represent two capacitors of value C, for example first one, and 4C in parallel. Okay, so V is constant, D is constant, implies that electric field is also constant. So E becomes 4 kV per centimeter. Option C is the correct option. Thank you.